Good morning. So today we'll solve some problems on the inverse Laplace transform. Some functions are given and we have to find the inverse Laplace transform. Example first, find the inverse Laplace transform of the following function. The function is given x of s is equal to 2s cube minus 9s square plus 4s plus 10 divided by s square minus 3s minus 4. So first we have to check the whether this is a proper function or improper function. So here this is a m. This m is here is greater than the order of the denominator polynomial. Order of the numerator polynomial is greater than the denominator polynomials. Therefore, we can say this is a improper rational function. Okay, so this is improper function. So what we have to do, we have to use here the long division method. Okay, we have to use here the long division methods. So use long division method as the sum of a proper rational function and a polynomial in yes. So as we have concluded that this is an improper rational functions and we have to use the long division methods. Therefore, the given transfer function can be written for the long division methods. So 2s cube minus 9s square plus 4s plus 10, and this is divided by s square plus, it is minus sign is there, minus 3s minus 4. So we have to use this long division method. So here we require the 2s cube, but here it is a s square. So we require here 1s. We require here 1s, and this is a 2 is here. Here it is 1. So here we also require 2. Now we have to multiply this whole equation by 2s. So 2s into s square. So this is a 3s cube. 2s into is 3s. So this is a minus 6s square. So 2s into 4. So this is minus 8. Yes. Okay. So subtract this equation so that this first term will get cancelled what will remain here? Minus 3s square, and this is a plus 12s plus 10. Okay, so now again, what we require here? We require here 3s square. So s square is already there, so we require here 3, and we require here again minus sign. So s square is already there. So if you multiply this minus 3 to these equations, whatever the equations we have to write here. So minus 3 into s square, it is a minus 3 into s square. Minus 3 into minus 3s, it is a plus 9s. Minus 3 into 4, it is a plus 12. And now if you add this equation at these values or subtract these equations, so this term, first term should get cancelled. Okay, now this is cancelled. So what is remain here? It is remain 3s, and this is minus 2. Okay, so this is the long division methods, and we have got now whatever the terms we have got, we rewrite like this: x of s is equal to, this is the 2s minus 3 plus this term 3s minus 2 divided by s square minus 3s minus 4. Okay, now use a partial fraction expansion to expand this rational function. Use partial fraction expansion to expand above equation. No, so we can write here x of s is equal to 2s minus 3 plus 1a over, we can write here, first we'll write here 3s minus 2, and what are the factors of this equation? The factor of this equation is s plus 1 and is s minus 4. If you write in the factor form, so now we can find this 2s minus 3 plus a over s plus 1 plus b over s minus 4. So we have to find these coefficients a and b. How we can find this coefficient? Again, a is equal to s plus 1 into x of s at s is equal to minus 1. So s plus 1 into, what is x of s is here? X of s is 3s minus 2 divided by s plus 1 s minus 4 at s is equal to minus 1. This will get cancelled, and if you substitute here values, now s is equal to minus 1, so it is minus 3 minus 2, this is minus 1 minus 4, so minus 5, this is minus 5, so this is equal to 1. So what is value of a? A is 1 here. Okay. Next we have to find the coefficient b. The coefficient b is found as plus 2 into x of s at s is equal to minus 2. Therefore s of x is plus 2 and x of s is 3s minus 2 divided by s plus 1 s plus s minus 4. Okay, so this is actually the term is the s plus s minus 4. The b coefficient is not 2, so it is a s minus 4. This is minus 4. Okay, so this is at, so this is also at s is equal to 4. Okay, so this is at s is equal to 4. So s minus 4 is cancelled. So this is what we got here now. This 3 into 4, and this is s plus, that is 4 plus 1, 5. So 10 upon 5, 2. So this is value of p. So we have got here the constant of b is 2. Now we have to put this constant values in the equation. 2s minus 3 plus 1 over s plus 1 plus 2 over s minus 4. Okay, now find the inverse Laplace transform of above equation. So if you take the inverse Laplace of x of s, it is x of t. And what is the inverse Laplace transform of this term? So this is 2s. So it is a 2 into del of 1 of t, and this is a 3 into del of 3, the second term, this 3. And what is the inverse Laplace transform of 1 over s plus 1? So it is e raised to power minus t into u of t. And what is the inverse Laplace transform of this? It is again 2 into e raised to power 4t into ut. So this is the inverse Laplace transform of the given transfer function. Okay, so this is the solution. Second equation is example 2. Now x of s is equal to minus 5s minus 7 divided by s plus 1, s minus 1 and s plus 2. Now we have to first check whether this is a proper rational function or improper rational function. So what is the power of numerator polynomial? It is 1. Okay, this is power of s is 1, but here the factors are 3. So we have to multiply first and then we have to find the factors. Order of this denominator polynomial. Obviously it is greater than 1. Obviously the order of the denominator polynomial is greater than the numerator polynomial, and therefore we can say it is proper rational function. Because here m is less than n. Okay, so if m is less than 1, we can directly expand this using the partial fraction expansion to expand this function. Therefore, x of s is equal to a over s plus 1 plus b over s minus 1 plus c over s plus 2. Okay, so find out this coefficient first. S plus 1 into x of s at s is equal to minus 1. So what is x of s is here? So this is s plus 1, and what is x of s is here? Minus 5s minus 7 divided by s plus 1, s minus 1, and this s plus 2 at s is equal to minus 1. So this factor will get cancelled, and in the remaining terms we have to substitute here s is equal to minus 1. So minus 5 into minus 1, it is 5, and this is minus 7. Again here minus 1 into minus 1, this minus 2 into minus 1 plus 2, this 1. So minus 5 minus 2, oh, sorry, 5 minus 7 minus 2, and this is minus 2. So it is 1, and therefore value of A is 1. Value of A is 1 here. Similarly, we find the value of B and C. So what is B factor? Corresponding factor of B, it is s minus 1 into x of s at s is equal to 1, and therefore s minus 1 x of s is again minus 5s minus 7 divided by s plus 1, s minus 1, and this is s plus 2 at s is equal to 1. So s minus 1 will cancel here. What will remain there? So minus 5s minus 7, and this is s plus 1, s plus 2. Put the values of s is equal to 1. So here minus 5 minus 7. So this is 2 into 3. So minus 12 into 6. So here value is coming here minus 2. So this is value of B. Okay, B is minus 2. Now we have to find the value of C. And therefore C is equal to, what is the coefficient of corresponding to term C? It is s plus 2. X of s at s is equal to minus 2 equal to x of 2 and minus 5s minus 7 divided by s minus 1, s plus 1, s minus 1, and s plus 2 at s is equal to 2. So this s plus 2 is cancelled here, and if you substitute now the in remaining terms, s is equal to 2. So this is a minus 10 minus 7 divided by, this is a 3, and this is 1. So it is a minus 17 by 3. Okay, here we are substituting here s is equal to, sorry, we have to substitute here s is equal to minus 2. I have to substitute here s is equal to, put here s is equal to minus 2, and therefore -2 and -5, 10 -7, and this is -2 and -1, this is -1 into -2 -1 -3, and therefore this is a 3 divided by 3, and this value is coming equal to 1, and therefore this is a C. So what is the value of C is here? It is 1. Okay. So the next is where to substitute this in the given expanded equation. X of s is here is, we have got 1, we have got here is 1. So 1 over s plus 1. S plus 1. What is the value of b? C, we have got here 1 over s plus 2, and this is s minus 1. So what is the value of b we have got? B is -2. So b is -2. So this is the equations. Now we have to take the taking inverse Laplace transform. Of above equation, and therefore the inverse Laplace transform of x of s is x of t, and what is the inverse Laplace transform of this is e raised to power minus t into u of t. Okay, so what is the, again this is 2 is here, and therefore e raised to power t into u of t. This is the inverse Laplace transform of this second factor, and the third factor is e raised to power minus 2t into u of t. So this is the inverse Laplace transform for the given transfer function e raised to power minus t u of t, like this. Next, we will take the example 3. X of s is equal to s square plus s minus 3 divided by s square plus 3s plus 2. So where to find here the inverse Laplace transform? Find inverse Laplace transform of this above equation. Okay, but here we have to again check the order of the polynomials. This is a numerator polynomials and this is a denominator polynomials. So m and n. So what we can say, this is equal to m equal to n, because here the order of the numerator polynomial is 2, order of the denominator polynomial is also 2, therefore m is equal to n, and we can say it is a improper rational function. This is improper rational function, and therefore we have to use the long division method. Use long division method as the sum of the proper rational function and a polynomial in S. So use the long division methods, and therefore we have to use the long division method. So this is a s square plus s minus 3, and this is s square plus 3s plus 2. Okay. So we have to use here this a square is already there, a square is already there. Therefore, we have to use here 1. So we have to use here 1. So 1 into a square plus 1 into 3s plus 1 into 2, this is 2. Okay. Subtract these two equations. So this s square will cancel. What will remain here? Minus 2s will remain, and this is minus 5 will be there. Okay. Now, using the partial fraction expansion, we can write here x of s is equal to what we have got here 1. We have got here 1 plus minus 2s minus 5 divided by this s square plus 3s plus 2. Okay, so we can write here this a again we can, what are the factors of this? It is a s plus 2 s plus 1. So we can write here a over s plus 1 and this b over s plus 2. Okay, now again we have to find the value of a and b. So a is equal to s plus 1 into x of s at s is equal to minus 1. This is plus 1 and 2x of s is minus 2s minus 5 divided by s plus 1 s plus 2. This will get cancelled. Put here s is equal to minus 1. So this is minus 2 into minus 1, 2 minus 5 divided by minus 1 plus 2, 1. So this is a minus 3. This is minus 3. Find value of b. B is again s plus 2 into x of s at s is equal to minus 2, and therefore this s plus 2 into minus 2s minus 5 divided by s plus 1 s plus 2 at s is equal to minus 2, s plus 2 is cancelled. So put value of s is equal to minus 2. So it is a 4 minus 5 divided by minus 2 plus 1 minus 1. Therefore, it is a minus 1 by minus 1. It is equal to 1. Okay. So here coefficient a is equal to minus 3 and coefficient b is equal to 1. You can put this value in the given equation. This equation equation number, suppose we can give here equation number 1. So in this equation we have to put x of s is equal to 1, x of s is equal to 1 minus value of a is minus 3. So this is s plus 1 and b we have got here 1, therefore this is s plus 2. Okay, now we have put here value of a and e is minus 3 in this equation, minus 3 over s plus 1. Okay, so now we have to find the inverse Laplace transform. So taking inverse Laplace transform of above equation, so we will get here x of t. What is the Laplace transform of uh, inverse Laplace transform of 1? It is a impulse function L of t, and what will be here? Here it is minus 3 into e raised to power minus t into u of t plus e raised to power minus 2t into u of t. And this is the inverse Laplace transform of the given transfer function. Okay, thank you very much.